Okay, welcome back to another video. So the Crooken hydroelectric power station in Scotland is built inside a mountain. Water from a lake near the top of the mountain flows through the straight pipes to a generator. The pipes have a length of 350 meters and are inclined at an angle of 55 degrees to the horizontal. Okay, the gravitational potential energy of the water in the lake is used to generate electrical power. In 1 minute, each pipe transfers 1,700 meter cube of water to the generator, and the density of the water in the lake is 1,100 kilogram per meter cube. And you have to show that the power transferred by water in each pipe is about 88 megawatts. So first you have to understand what's actually going on. So water is going to be flowing from the straight pipes to the generator. So as the water is going to be going down, it's going to be losing its gravitational potential energy, and that gravitational potential energy is going to be converted into the electrical energy of the generator. Okay, so this decrease in the MGH, so the decrease in MGH is equals to the increase in electrical power. Now, we know we can calculate the decrease in MGH using the formula of mg and h, but we do not know the mass. So we have been given the volume and the density, and we know density is equals to mass over volume, and mass is density times volume. So instead of MGH, I can write rho VGH is equal to the electrical energy transferred. And I'm going to divide both sides by time, so I'm going to get the power that's transferred to the electrical generator by the water in the pipe. So the power transferred is equals to rho VGH divided by time. So again, a diagram to help you understand. The water is going to be flowing down, and as it's flowing down, it's going to lose its gravitational potential energy. And that loss should be going somewhere else, and that's going into the energy of the generator. And we can divide both things by time to get power that's transferred when by the water when it flows through this pipe. Okay, so we know the values. We know density is 1,100. We know volume is 1,700, 9.81. And the height here has to be now remember, when you do MGH, the h here is the vertical height always. So we have to take this vertical height, right? And that's going to be 350 sine 55, okay? 350 sine 55. You can use the SOHCAHTOA as well, but just remember that this is 350 sine 55. Because if you remember, in projectile motion, this is going to be 350 sine 55, and this is going to be 350 cos 55. So I'm going to take this and plug in there for the height. So 350 sine 55 over 1 minute, which they told us, and that's going to be 60 seconds. So that's going to be 87.6 times 10 to the raised power of 6 watts. If you're going to change the units, then we know times 10 to the raised power of 6 is going to be mega, so we're going to get 87.6 megawatts, which is approximately 88 megawatts. Now it says water is going through these 4 identical pipes. So we have the 4 pipes, and we know that each pipe transfers an energy of 87.6 megawatts. And then we have 4 pipes, so I'm going to times it by 4. So that's going to give me 350.6 megawatts. Now, this is the total energy, total power. So this is the total power input, okay? So we're going to be inputting 350.6 megawatts. Out of these 350.6 megawatts, 256 megawatts is wasted, and then we get the power output. So this is the input, power wasted, and power output. So the power output that we're going to be getting is 94.6 megawatts. Okay, so we're giving some input, and then some of it is getting wasted. So the energy transferred by the pipes is going to be 350. But not all of that energy will be transferred efficiently. Some of it will be lost, and the rest will be the output. Now this is going to be the power that will be used by the generator to have its electrical power. And yeah, now we're going to apply the formula power output divided by power input. So 94.6 divided by 350.6 times 100. You don't have to change the units. The megawatts and the megawatts will cancel out. So you're going to end up with the answer of 26.9%. That's your answer.